Welcome to CODECO UCC3, Media Delivery Systems across a Decentralized Edge Cloud Continuum. In this video, we will demonstrate how CODECO helps address the growing challenge of massive media traffic. In today's digital era, media traffic constitutes a significant portion of network activity, driven by the widespread adoption of high-speed internet and smart devices. As video streaming, online gaming, and social media become integral aspects to daily individual routines, network operators and media content providers face the challenge of optimizing infrastructure to enhance service delivery and its associated quality. CODECO addresses this challenge by optimizing media delivery system management through virtualization, AI-based engines, and real-time network updates, all in all, improving connectivity and resource utilization. The key functionality of this use case is to provide content providers with visibility into the client zones, allowing them to associate these zones with the nearest cache locations. To achieve this, Use Case 3 leverages MEC APIs to retrieve and integrate this critical information.
The MEC framework was designed to bring cloud computing capabilities closer to the edge of mobile networks. This allows for low-latency, high-bandwidth services by offloading processing tasks from centralized cloud servers to local edge servers that are physically closer to end users. The MEC Location API, which we implemented according to the 3GPP specification, is designed to deliver real-time, location-based services by utilizing the edge infrastructure. The MEC Location API is deployed in a Kubernetes environment and consists of two simple pods, the database and the API. After we deploy the MEC API and make sure it is up and running, we can test the basic functionality. Using the user's endpoint, we can list and access detailed information about all UEs or query the location of a specific UE the application is interested in. We can also list all UEs in a specific zone, which is a predefined area where tracking applies, like a city block or a high-risk part of a factory. We can access detailed information about zones using the zone's endpoint. The MEC Location API is particularly useful in retrieving distance information in real time using the distance endpoint. Our implementation works hand-in-hand with CODECO. Specifically, the MEC API can be deployed as a CODECO application, where CODECO selects the optimal placement node to satisfy the user's conditions.
In this use case, there are three main stakeholders who will benefit from this technology. On the one hand, we have the owners of the data centers, who will be able to perform a dynamic and intelligent management of the resources that enable each of their clients. On the other hand, we have the content providers, who will have a clear and dynamic view of the status of their caches and the network that connects them, being able to perform a content distribution that minimizes latencies and redundancies. Finally, we have the consumers of this content, who will be able to access the content in an agile and dynamic way, regardless of whether they are in static or in motion. CODECO framework optimizes media delivery systems operations through dynamic resource allocation, real-time network health updates, and intelligent cache management. Moreover, this is not a work that stops here. This scenario is being continuously improved with the aim of providing extended connectivity to multi-cluster environments and improved network anomaly detection to ensure stability and quality of service in the future. If you're curious to know more about CODECO and how it works, don't hesitate to visit our social media and our official website. Thank you very much, and have a nice day.